Hello everyone, you're welcome to solve this nice algebra problem. So which is x plus y, this is equal to 5, we can call this equation 1. X times y, this is equal to 50, we can call this one equation 2. So the question here, what is the value of x and what is the value of y? So if it is your first time you come across videos from this channel, kindly like and subscribe. Kindly like so that this video can be recommended to other viewers. Now, solution here from equation 1, which is x plus y, this is equal to 5. We can make y to be the subject of the formula. That is, y will be equal to 5 subtract x. Let's call this equation 3. Now, from this equation 3, let's substitute equation 3 into equation 2. So equation 2 is x times y. This is equal to 50. So substituting the value of y, we'll have x times 5 minus x. This is equal to 50. So here we have x times 5, which is 5x, subtract x squared. This is equal to 50. So let's rearrange this equation. We have negative x squared plus 5x. Let's take 50 on the left-hand side, so minus 50. This is equal to 0. And then the next step, let's multiply both sides by negative 1. So negative 1 times minus x squared, this is x squared. Then minus 1 times plus 5x, this is minus 5x. Then minus 1 times minus 50, this is plus 50. So this is equal to 0. So here we form a quadratic equation of the form ax squared plus bx plus c, this is equal to 0. So this implies that from this quadratic equation, a is equal to 1, b is equal to minus 5, and c is equal to 50. So the next step here, let's determine the discriminant value so that we can assess the nature of this quadratic equation, which is b squared minus 4ac. Let's substitute here. This is minus 5 squared, subtract 4 times a, which is 1, times c, which is 50. So minus 5 squared, this is 25, subtract 50 times 4, which is 200. And that implies that here we have 25 minus 200. This is minus 175, which is less than 0. So this implies here we have two complex roots. We have two complex roots here, which we can solve by applying the quadratic formula. That is x1, x2 can be solved by applying the quadratic formula. That is minus b plus or minus the square root of b squared minus 4ac, all this divided by 2 times a. To solve for the value of x1, x2, we apply the quadratic formula, which is minus b plus or minus the square root of b squared minus 4ac divided by 2a. Substituting the values of a, b, and c, here we'll have minus 5 plus or minus the square root of b squared, this is minus 5 squared, subtract 4 times a, which is actually equal to 1, times c, which is equal to 50, all this divided by 2 times 1. The next step here, we have minus times minus 5, this is 5, plus or minus the square root of negative 5 squared, which is equal to 25, subtract 50 times 4, this is 200, all this divided by 2 times 1. Now here we have 5 plus or minus, we have that 25 minus 200, this is minus 175 divided by 2. The next step here, we have 5 plus or minus, we can express minus 175 as 25 multiplied by 7 multiplied by minus 1, all this divided by 2. Now, the second step here, we have 5 plus or minus the square root of 25, this is 5. The square root of minus 1, this is I. Then square root of 7. All this divided by 2. So this implies that we have x1 equal to 5 plus 5I square root of 7 divided by 2. And we have x2 equal to 5 over 2 subtract 5I square root of 7 divided by 2. So let's solve for the corresponding values of y. Let's solve for the corresponding values of y. From equation 3, we have that y is equal to 5 subtract x. So that implies that y1 is equal to 5 subtract x1, which is 5 over 2 plus 5I divided by 2 square root of 7. And this is the same thing as we have 5 minus 5 over 2, which is the same thing as 5 over 2 subtract 5I divided by 2 square root of 7. So that implies that x1, y1, this is equal to 5 over 2 plus 5I square root of 7 divided by 2, 5 over 2 subtract 5I square root of 7 divided by 2. So this is the first set of solution. This is the first set of solution. So let's solve for y2. Let's solve for y2. Now let's solve for y2, which is equal to 5 subtract 5 over 2 subtract 5I square root of 7 divided by 2. So this is the same thing as 5 over 2 minus times minus here. This is plus 5I square root of 7 divided by 2. So we have that x2, y2, this is the same thing as x2 is 5 over 2 subtract 5I square root of 7 divided by 2. And then we have y2, which is 5 over 2 plus 5I square root of 7 divided by 2. So this is the second set of solution that we have. So let's verify here. Let's verify. Now, if you recall here, we end at x plus y is equal to 5 and x times y is equal to 50. So you have x plus y, this is equal to 5, and you have x times y, this is equal to 50. So we can verify this with equation 1. So let's check x1 and x2 if this satisfies x1, y1 in other words. x1, y1, which is this. Let's check if this satisfies the equation. Now we have 5 over 2 plus 5I square root of 7 divided by 2 plus y, which is 5 over 2 subtract 5I square root of 7 divided by 2. This should give us a value of 5. So you can see plus 5I square root of 7 divided by 2 subtract 5I square root of 7 divided by 2. This will simplify. And then now from here, we'll have 5 over 2 plus 5 over 2, which is the same thing as 5 over 2 times 2. This should give us a value of 5, which is true. Now let's check x2, y2, if this satisfies the equation. We have 5 over 2 subtract 5I square root of 7 divided by 2 plus 5 over 2 plus 5I square root of 7 divided by 2. This should give us a value of 5. So again here, minus 5I square root of 7 divided by 2 plus 5I square root of 7 divided by 2. This simplifies. Then here we'll have 5 over 2 multiplied by 2. This should give us a value of 5. So, and this is true that the left hand side, that is the left hand side, is equal to the right hand side. And that affirms that x1, y1, which is what we have here, and x2, y2, which we have here,